All right, so estimating limits from tables. So use a table of values and a graph to estimate the value of the limit as x approaches 0 of sine x over x. We usually just kind of plug it in, see if it doesn't, give you a 0 over 0. Look, in calculus, this 0 over 0 is called, as it is 0 divided by 0. What is 0 divided by 0? You put it in a calculator right now. What is it going to give you? Go, everybody, get your phone, get your decimals calculator thing out. Go ahead and put 0 over 0. What is 0 over 0? What does it say when you put it 0 over 0? What does it say? Does it say undefined or does it say error? What does it say in decimal? It says undefined? Okay. It's undefined. Undefined. Look. You really need to, and then put a big star next to it. 0 over 0 as it is, let's go with undefined. It's undefined. Okay? 0 over 0 is undefined. The limit, I should go over some limit rules here. So really, in reality, we're going to do the limit as x approaches 0 for this particular problem. X approaches 0 of sine x over x over, we kind of distribute the limit as x approaches 0 for each one of them. Over the limit as x approaches 0 of x. And these two things are different. They're not the same thing. This is 0 over 0 is just undefined. Whereas this is different than this. So now, what I'm going to do is actually plug in x equal to 0 here for this one. So what do we get if we do that? Let's just say do that. What's sine of 0? This goes back to pre-calculus. Let me see. That's why we did so much trigonometry. What's sine of 0? What's sine of 0? All right, look. If there's just anything you're gonna remember from trigonometry section, and you better know it, is this. The unit circle, not everything, but just this. What are the coordinates here? 1, 0. What are the coordinates here? 0, 1. What are the coordinates here? Negative 1, 0. And what are the coordinates here? 0, negative 1. You better know this, at least this. X is cosine, Y is sine. X is cosine, sine is y. X is cosine, sine is y. X is cosine, sine is y. Sine is y. So I'm doing sine. What's the sine of 0? What's sine of 0? Sine of 0 is what? 0. So when I say sine of pi by 2, sine of pi by 2 is what? You get it? Just remember this stuff. Okay, I'm going to stop. Sine of 0 is 0. So 0. And then if I plug in limit as x approaches 0 of x, is 0. So I'm getting 0 over 0 here, and you're like, what's the difference between this 0 over 0 and this 0 over 0 here? They are different. They're different because the answer here is not undefined. You're going to say, is the answer undefined? No, it's not undefined. It's just that it's called, this right here, this is going to be called indeterminate form. So whenever you have a limit as x approaches 0 sine of x over limit as x approaches 0 of x, this is called undefined. It should be just no, it's not undefined. It's called an indeterminate form. Indeterminate. Form. Really got to understand that, the difference between these two. So when it's just a 0 over 0 like this without no limits, it's undefined. and you say the limit x equals 0 of this is 0 over 0, then it's indeterminate form. Meaning that we don't know still what the answer is. The answer is not undefined. It's that we just still don't know what the answer is. All right. So now we're gonna do a graph because we got an indeterminate form. So we're going to do a table actually. And input values get closer and closer to 0. So we don't know what's happening here. We don't know what's happening at 0. Well, we're getting a 0 over 0 at 0. So now let's get closer and closer to 0, no? From the left and from the right. So it's, one more time, what am I going to say? It's arbitrary. We're like, where do I start here? Do I start with -1 or what? I think I'm going to start with -1. Or so x, f of x. I'm going to start with -1. Let's see. Well, 0 is there. And we don't know. I guess I just remember because I made this myself. So -1 is, so if it's going to be symmetric, what do you think is going to go over here? If I go from the number line, 1 to the left is -1. What's 1 to the right? 1, yes? Then what do you think I'm going to choose? And then I'm going to get what? Closer and closer to 0, yes? We're going to close to 0. What do you think I'm going to choose here? Huh? 0.5. You're negative 0.5. And then on the right, it's going to be what? To be symmetric, you understand what's going to be on the right? 0.5. And then what do you think my next choice is going to be? Oh, 0.05 would be nice. Somebody said 0.05. Negative 0.05. Is that what I'm using though? No, I'm using 0.01. And so here just on being, it's whatever that word I said. But anyways, you're getting closer and closer to 0. You better not be putting no -10 or something weird, because we're not going that way. We're going closer and closer to 0. And so this is going to be 0.001. No, 0.01. I mean, and get out your decimals calculator. Actually, get your phones out, and we're going to get doing it like this. So what we're going to do is we're going to do what? We actually are going to plug in what? Sine of what? Sine of -1 divided by -1 to get the answer to this. So I know that we don't have graphing calculators right now, but we would be using graphing calculators if you were taking actually AP, and we'll put in that. But decimals is probably just as good for this thing here. So what is the answer to sine of -1 over -1? Come on, get your calculators and have it ready for all these inputs. All you're doing is just changing the what are you getting? It's going to be an approximation, I think. What is it? Come on, somebody. 0.84? Would it be the same for +1? Would it be the same? Probably symmetric, maybe. I don't know, but I'm pretty sure it's symmetric. What is sine of 1? Sine of 1 over 1. Just change it real quick. What is it? Is it the same? It is symmetric? Oh, I'm going, I guess, straight that way. Plug in -0.5. What's -0.5? What do you get it for when you plug in -0.5? Point what? 9.96, yes. And if you plug in -0.01? What is it? 0.9? 0.9999998. Oh, like, and you're like, to where do you stop? I don't know why I did so many, 1, 2, 3, 4, 5 decimal places. But probably, if you do 3 decimal places, you would have gone 0.998. Because you have to, like, truncate, or no, you got to round. And it is symmetric. So coming from the left, what's the limit as we come from the left? What's the limit as we come from the left? What do you think is going to eventually trying to get to? 1. And what's the limit as we come from the right? 1. Is the left limit and the right limit the same? They're both approaching 1. So what can you say about what the limit is? The limit, as x approaches 0, of this function is what? 1. That's it. That's the lesson for today. And this is the graph. If you want to just plug that into the graph, you could see it. Coming from the left and from the right, the answer is 1. But it actually, it should be open here. The graph, it should be an open circle because it's not defined there. Oh, there it is. So the limit of f of x as x approaches 0 is 1 of this function. All right. You guys got that? All right, let's move on. Problem number 2. Use a table of values and a graph to estimate the value of lim x approaches 1, x minus 1 over x squared minus 1. So if we just go ahead and plug in x equal to 1 into that function there. So if we actually just plug it in, what are we getting there? Can you do this in your head quickly, or do I just copy this down? If you plug in 1 on top, what are you getting? If you plug in 1 for the top of the fraction, what are you getting? What? If you actually plug in x is 1, plug in 1 here. What's 1 minus 1? 0. And then if you plug at the bottom, what are you getting? 0. So we're getting a 0 over 0, which is, we're doing a limit here. It's called indeterminate form. So we can go ahead and do more work here. So we're going to use a table. And so we don't know what's happening here at the very, at 1. We don't know what is really happening. But we don't care about what exactly is the output of it. We're just trying to see what is it approaching from the left and from the right. That's what limits are. So we don't know what that is at 1. And what do you think we're going to choose the leftmost? What do you think I'm going to choose here on the left? What did you say? It's just throw out a number. What do you think? Huh? No, come on. This is 1. What's the number to the left? What's the number to the left of 1? Did somebody say 3? You guys know a number line? Let me draw a number line for you guys. So 0 is here, 1 is here, 2 is here. What's the number to the left of 1? What's the number to the left of 1? You're like, a whole number, like a 0. Is 0? Let's go with the 0 be a good number. Is that really what I'm using though? Hold on, let me see. But it's 0.5 to the left of the 1 though. Is 50 cents less than $1? Good question. Anyways, 0.5. If we're going to use 0.5 and be symmetric, what am I going to put on the very right side? 1.5 is good. Yeah, 1.5 is good. What do you think I'm going to use next? Let's go with -5. I'm messing with. What number should I? What do you think I'm going to use next? 0.1? Somebody say 0.1? Let me see. What? That's not right. This is dumb. I'm dumb. Oh no, I'm getting closer. Woo! I'm getting dumber. Hey, is 0.99 close to 1? Is 99 cents close to $1? Yeah, that's correct. Oh, so over there is going to be what? What's going to be right here? What's going to go here? 1.01? Did somebody say 1.01? Yes? All right, what am I going to put here? What do you think I'm going to put here? 0.999, probably 0.999. So what's going to go on the right? 1.01? 1.01? Oh, 1.001. Yeah. Get your calculators again and then put in the numbers. So what's it for 0.5? What is it for 0.5? 0.667? Yeah, if you're asking like, hey, to what do we round, or how many decimals or whatever, I you know what, just do to the nearest thousandth, I guess, for consistency maybe. So 0.99. What is it for 0.9? Now, it's not always symmetric. You see, they're like, oh, is 0.667 here and 0.667 here? No, not always. Sometimes, but not always. But anyways, let's do 0.99. What is it for 0.99? What is it? 0.502? If you plug in 0.999, what is it for 0.999? 0.500. Let's come from the right. 1.001. What are you getting? You got it, Evelyn? Oh no, I don't know why I'm getting 0.500. Is it or rounded? Is it? Oh no. Rounded it would be, no? And so whatever, like the other one is going to be whatever. I'll give you the numbers, 0.498 and 0.40. So as you see that it's coming, it doesn't even matter. As long as the left limit and right limit look like to be the same, then the limit will be, what is the limit? 0.5, or you could say it's 1/2. So if you want to see the graph, I can give you the graph of it. There's the graph of the function x minus 1 over x squared minus 1. And as we come with Brian's little car here, well, he got, I don't know, he does it like this, and he's driving like this, and you see this 0.5, and then coming from this side is the same. You don't have to be drawing this, whatever. Let's move on. You want to draw it, go to the website when I open it. All right, let's finish off. I think this will be hopefully the last one, number 3. If f of x equals this function, create your own table of values to help you evaluate the limit as x approaches -2 of the function. So basically, again, one more time, if you look at it, you plug in x is -2 in here, x is -2, -2 plus 2 is 0 at the bottom. And if you put it at the top, you probably get 0. Let me see also. So you're going to get a 0 over 0, which is indeterminate. Yeah. So on the left, I'm choosing, again, this goes into the arbitrary. At -2, I'm going to go a little bit more to the left, -2.05, just to finish this off. I think, and then -1.95 on the right. I think this is getting repetitive, and these are the numbers, and these are the numbers. And from the right, this is the number, and this is the number. Because it's kind of repetitive. What's the limit then? If the left limit is the same as the right limit, then it would be that is the limit. What is the answer? 21. Yeah, well, this is actually coming from the top, and this is coming from the bottom in terms of y. One is going like, but they're going towards the first. 21 is the limit. I think that is it. That should be good enough for right now. There's one more, problem number 4, but you can figure it out on your own maybe if it's on the homework. I'm going to stop this and let me see if I